Good morning, everyone. How was everybody's weekend?
Good.
Good? Do anything exciting?
Yeah.
Yeah? What'd you do?
I went to Montreal.
You went to Montreal? What'd you do in Montreal?
I went to my brother's hockey tournament.
Oh, that's cool. Did you have fun?
Yeah.
Oh, right on. Anybody else? Anything to share? No? Alright, we'll just do a quick little attendance here. Elliot Richard, are you here?
Yeah, I'm here.
Isaac Richard? Very good. Everybody's here. Alright, today we're going to start by introducing to you the semiconductor shortage. Does anybody know what that is? Anybody heard of it?
No clue.
No clue. Alright, we'll look into it. I got a question for all of you. Would you be able to survive without an Xbox or a PlayStation? Yeah, you think so? Would you be able to survive without your phone? I don't know. I think we all like our phones and our Xboxes. No? Yes? Maybe? Well, these are all things that require semiconductors, and right now there's a big shortage in the world. And it's not only for personal devices, but anything from cars to anything that has electronics or computers built in, there's a big shortage. Alright? Let's look into it. We're going to do a quick review on insulators, conductors, semiconductors, and transistors that we've learned earlier in this unit. Can anybody tell me what an insulator is? Does anybody remember what an insulator is? Hazard a guess, Elliot? No? Does it insulate electricity?
Yeah.
Yeah? So an insulator does not allow electrical flow. Remember? So let's look at it again. An electrical insulator is a material in which electric current does not flow freely. How about a conductor? Does anybody remember what a conductor is? Anybody want to have a guess at what a conductor is? Elliot?
The front of?
Does it conduct electricity maybe?
Yeah.
Yeah? So it allows electricity to flow freely?
Mm-hmm.
Alright. A conductor are materials that permit electrons to flow freely from particle to particle. So remember when we did the atom with the electrons, where the electrons flow freely, a conductor lets them flow. And then a semiconductor. Any idea? Does anybody remember semiconductors? That was like a whole week ago, right? Nobody remembers? Well, let's look at the name, semiconductor. Any ideas? Does anybody remember? So it's not a conductor, it's not an insulator, it's halfway in between. Whoa. Let's back it up a little bit. A semiconductor is a material material product usually comprises of silicon, which conducts electricity more than an insulator, such as glass, but less than a pure conductor, such as copper or aluminum. Their conductivity and other properties can be altered with introductions of impurities called doping to meet specific needs in the electronic components which it resides. We all remember this now?
No.
Remember the lab that we did with transistors? Does everybody remember transistors? When we had the breadboard and we put the transistor on there and we put electricity to the base and then we saw the flow go through it, it was an electronic switch. That's basically what we came up with when we did that lab. So a transistor is a current-driven semiconductor device which can be used to control the flow of electric current, in which a small amount of current in the base lead controls a large current between the collector emitter. So remember we put a little bit of voltage on the base and then it lit up the light just like a switch would do. Remember it looked like this on our breadboard. So now we're going to dive into a little video that explains the shortage and how semiconductors are made. Now remember, we live in southwestern Ontario, or Ontario as a whole, is very, very reliant on manufacturing. And all manufacturing, automotive, electronics, everything is very reliant on semiconductors. Yes, Isaac?
I know what we're talking about.
That's okay, buddy. So we're gonna go ahead and look at this video, and I want you to look at all the big companies that are in there, because those are all companies that are leaders in the manufacturing world, and possibly a future job for anybody.
This chip controls your car, stores data about what you bought, and runs the software on your laptop. These chips have come to power our lives, and only a handful of fabrication plants or fabs in the world have the know-how and infrastructure to make them. So most of the chips are produced outside of the US, like at this fab in Singapore.
To build a fab is a big investment.
And now the world is running out of chips because companies can't make them fast enough.
When order really flooding in, we had to turn on every single piece of machine that we can find in the factory.
The pandemic rattled supply chains and led to a surge in demand for electronics when people were stuck at home. While the perfect storm of natural disasters, a fire at one of the world's leading auto chip makers, and the ongoing US-China trade war disrupted the production and distribution of semiconductors. This shortage has affected whether you can drive a Jeep off the lot or buy a new PlayStation 5. We visit one of the world's largest contract chip makers to see the complex process and why there's no quick fix to the supply crunch.
Chip usually takes about 2 to 3 months to make.
Daniel Rajkumar is a manufacturing manager at one of the fabs at Global Foundries. The American company is the third largest contract chip manufacturer in the world. Companies like Intel, AMD, and Bosch give some of their circuitry
These
designs
companies
to Global
exist also
Foundries.
in North America.
And then its fabs like this one in Singapore manufacture the chips.
Once we finish the fabrication of the circuitry, it has to go for testing, it has to go for repackaging.
Altogether, it could take as much as 6 months before a chip is ready to go into your tech. This long process starts here, at the center of the fab called the clean room.
Before going into the clean room, we need to gown up.
Because chips can be as small as a fingernail and crammed with billions of components, they have to be handled with great care.
Any form of dust that falls onto the wafers, it will cause the chip to be affected. And then now we are able to go into the air shower.
Global Foundries says this clean room is 1,000 times cleaner than an operating room. And it also takes up a lot of space.
2 football field, that's how big it is. We have about 700 to 800 machines.
It's also yellow in here because chips are sensitive to UV rays, and this lighting has none of that.
This is always the first step.
The starting material for any chip is here in this room. These super thin discs are called wafers and made from silicon. Eventually, one of these will produce about 1,000 to 1,500 individual chips. But before it does, the wafer is placed in a special container.
We have the raw silicon. We are now trying to register this material and transfer it into our wafer carrier.
Each carrier can hold up to 25 wafers, and there are about 4,000 of these moving around the facility at one time.
We are also the source of particles when we go into the clean room.
So never once during manufacturing does the wafer come in contact with any of the workers.
It will bring the wafers directly to the machine, and in this foundry, basically 95% of all processing jobs is fully automated.
These raw wafers are cleaned before starting a process that Rajkumar describes as similar to making layered cake.
The main function of a diffusion furnace is basically to grow layers of oxide or to dip a nitride onto the silicon.
That creates a protective coating. Next is a layer that makes the wafer light sensitive, so it's ready for one of the most important steps called lithography.
This is the most expensive module in any wafer foundry. The number of lithography machines will define how many wafers you can produce in a month or a year.
One lithography machine can cost anywhere between $25 million to over $100 million. And that's because it's responsible for adding layers of the circuitry, basically electronic components like transistors and diodes, that allow the chips to eventually store data or run apps.
What I'm holding here is basically...
So these are microscopic transistors, not like the ones that we used on our bread.
Inside this pink box is a photomask, which
They're
is like a
printed
glass
onto the
sensor,
wafer.
and clients send these directly to Global Foundries. The lithography machine blasts UV light through the photomask and prints patterns on the wafer over and over again. The difference between an advanced chip for a 5G smartphone versus one for your credit card comes down to the type of wavelength that's used. Shorter wavelengths mean you can etch finer features and get more performance out of the chips. Some of these transistors are so small that they're measured in nanometers and compared to DNA strands.
Much smaller than ones we
Once a
use.
circuitry pattern is imprinted, the wafer has to be charged.
These machines use a lot of energy to produce electrical charge that allows the electrical to flow to the chip and also creates the different type of function for your electrical chips.
Rajkumar says many of these steps are repeated hundreds of times before the fabrication is complete. And to get to this point,
Pay attention,
these
Isaac,
orders
there's
have
a
to
test
be made
up
at
here.
least a year in advance.
I have demo wafers here.
The finished wafers are tested, then finally sliced into individual chips.
One is the small die wafers, which is mainly used for bank cards or chips. And then you have the other one, which is the bigger die wafers, which can go into other kind of applications like computer processing chips or electrical appliances.
Isaac, sit down.
Global Foundries says its fab in Singapore typically makes about 600,000 wafers a year. But with the recent surge in demand, it's making around 120,000 more.
This whole year is fully booked up. We don't have any more space for new customers.
Tan Yu Kwong is the Vice President and General Manager of Global Foundries Fab 7 in Singapore, and he says there's no quick solution.
There's no space that you can house another lithography tool or any other tools that you like to buy. It is a lead time easily a 1 year to 15 months before you can see a tool that is coming into your factory.
It's not just a backlog of equipment, but Tan says expanding or building a fab from the ground up would require deep investments, more than the $1.4 billion that Global Foundries has already committed to spend this year on expanding its 3 fabs around the world.
You easily need to spend 7 billion to 15 billion depending on the size of
You're
the
distracting
factory you want to build, and the
everybody.
technology that you're going to develop can easily take you decades to build the foundations.
So to fill as many orders as quickly as possible, the company turned on idle machines and opened this factory control tower. Engineers here have a bird's eye view of the entire fab, and the green boxes show which machines are running at max capacity. Before this control tower, when there was a problem, engineers had to sort through data and piece together information themselves.
Compared to today, just looking at the screen, you already know that this is a piece of machine. You need to pay attention now.
Tan says any time saved is precious, but to truly address the shortage, the company is working more closely with its clients, suppliers, and the government.
We're going to continue seeing more government support because it is becoming such an important part of the entire global supply chain.
There's no reason why America should wait. We're investing aggressively in areas like semiconductors and batteries.
The Biden administration has proposed $50 billion to boost America's chip production. That's because while the US is one of the largest semiconductor markets, the majority of the complex and expensive manufacturing happens at a few companies based in China and East Asia.
That's because the world's biggest foundry in the world, TSMC, is located in Taiwan. Samsung also has a sizable foundry, as well as some Chinese players.
This concentration of fabs means any disruption to the supply chain, like a drought in Taiwan or political tensions with China, can have big ripple effects, especially when global demand is expected to grow by more than 12% this year.
We have technologies like 5G and artificial intelligence, and these types of advanced technology means that more chips will be needed to operate the devices that we use every day.
To meet that demand, the Chip Industry Association says it will require an investment of $3 trillion globally over the next 3 decades. So for us to buy new devices, Tan says his fab will work around the clock as it turns this challenge into a business opportunity.
From the ambitions of wanting to grow the company, this is definitely a positive point for us. This over demand is going to be around for long.
All right, does anybody have any questions? Comments on the video? Did anybody find it funny that the control room that they added to help the chip production, you would need a lot of chips just to build that control room, yet there's a chip shortage? It's kind of ironic, right? Like I said, Ontario is really heavy on manufacturing. So I'm sure you have a parent, an uncle, a family member, aunt that might be working at an automotive plant or a supplier plant. Right now, there's massive layoffs going on because of this chip shortage. And I want you to realize that this is a big problem around here today. So what I want to do is I've secured some time at the computer lab today, but before we grab our things and go there, we're going to talk about the research assignment. So what we're going to do is we're going to have a research assignment on one of two topics. Either we can describe the present day effects of the storage on today's society. I want you to research how and why it's affecting today's society, and maybe come up with some creative solutions. These can be your own solutions, these could be solutions that you researched, but I want to see some creative solutions. Also, you can add statistics in there. That always helps a research paper, but make sure when you add statistics that you do your citation. Because I just don't want you to say, you know, we lost 1 million jobs. You need to see the research of where we lost 1 million jobs. Or we can do topic number 2, identify the economic and social benefits and the possibility of manufacturing our own semiconductors here in Canada. Again, we are already built for manufacturing here in Ontario. Why couldn't we build our own semiconductors? I want you to research how and why we can do this and the benefits that might have on today's society. Again, if you're using statistics, I'd like you to cite all your statistics. Does anybody have any questions? No questions? All right, grab all your things. We're gonna go to the computer lab. We're gonna title this so I know which topic you're using, and the minimum is 1 page double spaced, okay? Let's try to get this done today. If we don't get this done today, the rest is homework for tonight, and we'll take it up tomorrow in class. All right.